All right, welcome back to another episode of Code with Akya. So today we'll be going to explore Kru- Kruskal algorithm, one of the most efficient ways to find the minimum spanning time of a graph. So if you're interested in finding or let's just say efficiently connecting the nodes in the graph while minimizing the overall cost, the Kruskal algorithm is a must know that you have to have in your list. So let's jump right into it. So by definition, Kruskal algorithm is a greedy algorithm which is used to find the minimum spanning time of a graph. It works by sorting all the edges of the graph by their weights and then adding edges one by one to the MST, ensuring that no cycles are formed. This is different from Prim's algorithm, which grows the MST from an arbitrary standing point. Alright, so this is by definition. Now let's just take a quick look at the steps of how do we actually perform it. So steps, then pseudocode, and then the coding screen. So all it takes is just four quick steps. Sort all edges of the graph is not in non-decreasing order of the weight. Pick the smallest edge and check if it forms a cycle with a MST formed so far. If it does not add to the MST, repeat the process until you have added v minus 1 edges, right? And then use the data structure called union find to detect and avoid cycles during edge addition. So that's how it works. So now let's just take a quick look at the pseudocode. So I usually highly recommend everyone you at home to have some kind of pseudocode in front of your computer screen, in front of your on piece of paper or on your mobile phone whilst you sit down coding, because it helps a lot. You can just go onto ChatGPT and can find pseudocode for anything, any data structures, any algorithm pseudocode you can find online. So when you have a pseudocode in front of you, you just know the steps, you just know how to. And once you know how to, it's going to be pretty simple to just write that into coding. It's basic English, you have to just translate it into Python. That's it, simple as that. And once you understand Python and English, you'll be able to code much better than most people, like 80 to 90% people in this field will be able to code better than them once you just understand how to read English and code both. All right, so onto our coding screen, the first thing we're going to be creating is a union find, as we have discussed in the steps. So basically it will find the disjoint set class for the Kruskal algorithm, right? So parent list range self rank, and then you just do the find, and you just do the union. All right, so the find is basically done. Return self dot parent u. Okay, so union, it has two of them, like a v and a u. So root u and root v will be our two variables that we will be using. Okay, then we'll just union them by rank, right? Union them by rank. So basically this is how it looks like. It's 4 o'clock in the morning. Kinda good. Feeling a little bit drowsy, but it's fun. It's fun. Yeah, it's fun. Okay, so dot parent root u equals to root v. Then else self dot parent root v equals to root u. Self dot rank root v plus equals to 1. Now it's time to move on to Kruskal algorithm implementation. So now we'll sort the edges by weight. Key lambda edge edge 2. Yeah, that's I think is going to be very okay. And then we have a union find, which is going to be basically finding the union for cycle detection. Then the MST total cost, initially 0 as always. For UV and weight and edges, you have dot find U does not equals to you have dot find dot V. MST append UV weight. Okay, total cost has to be plus equals to the weight, and then you just return the MST and the total cost. That's it, and that's how it's done. So now all we have to do is just create a graph that represents UV and weight, those three things, UV and weight, right? So we'll just create multiple rows up here, and once we create those multiple rows, we'll just do them real quick. Now create a vertices. I just take 6 for example. Then we'll be running our Kruskal algorithm. MST and the cost, Kruskal, graph and vertices. Then we'll just print the MST, minimum spanning tree, and the total cost of MST. That's what we want, right? So at the end we'll have the minimum spanning tree and the total cost of MST. And you have it. You have the minimum spanning time and the total cost of MST is 10. So this is how it's done. So that's how the Kruskal algorithm works to find minimum spanning tree. It's a simple and efficient algorithm for social network design problems when you want to minimize the total cost. If you enjoyed the tutorial, please subscribe. If you didn't, then don't hit the subscribe. So just if you want to get updated with more algorithms like this, then subscribe to Code with Akya. In the next video, we'll be covering topological sorting. So stay tuned and see you in the next one.